Okay, so as I was saying, we are adding and subtracting fractions. So let's just look at some plain old fractions first. Okay, so the denominators are the same here. So those are easy to add. You just add the top. So you get how much? You get 3/5. So here the denominators are the same. So we're just counting up how many thirds do we have. We have 5 thirds, but then we lose 2 thirds because this one is subtract. So 5 minus 2 is 3 thirds. And sometimes you have to kind of simplify or reduce at the end. Okay? So if you don't have the same denominator, you have to do something a little different. You have to find the common denominator, and we're looking for the least common denominator. Okay, so the smallest. You want to find the smallest thing that they'll go into, because if that way it kind of saves you a little bit of trouble. Okay, like 4 and 6, they'll both go into what? Into 12, right? So we would say, we would change their denominators to 12. Okay? So 4 times what is 12? 3. So that means I would multiply the top by 3. Okay? 6 times what is 2? Oh, I said it. 6 times what is 12? 2. So we would multiply the top by 2. Okay? And then you add. So you get 13/12. Okay, here you're subtracting. So 12 and 3 both go into what? Yeah, 12. You don't want to, don't overdo it and say 36 if you can help it, or 24. Keep it the smallest possible. So you don't have to change the 5 12s, but I should have made that a 12. Okay, so 3 times what is 12? 4, so that means you multiply the 2 times the 4. Now you subtract. What's 5 minus 8? -3/12. Oh, but that'll reduce, doesn't it? To what? They'll both divide by 3. Okay? So we always got to look to see if we can reduce things in the end. Uh-huh.
Number 3, could it be 1 whole and 1 12?
Yeah, you could say 1 and 1/12, but here in, Algebra 2 and Algebra 1 even, we leave a lot of them just as improper fractions, but that's a good question. In elementary school or intermediate school, when you first started learning fractions, they were like, oh, no, don't leave anything as an improper fraction, and then we change the rules on you in high school and say, yeah, just leave it, but that's just the way it is, isn't it? Okay, so here we go. We're going to add some rational expressions, okay? You're going to multiply by whatever's missing, okay? And you'll understand that in just a minute. So the first step is to factor each denominator if possible. So we look at the denominators and we factor them, okay? So x minus 1 doesn't factor, but 2x minus 2 factors. Those will both divide by what? 2. Okay, on the test yesterday, y'all were kind of stumbling over those and around those. Some of you were having a hard time factoring those. Okay, and they're easy. You're just overthinking or something or panicking. Don't do that. So when we divide that, we get 2 and then x what? Minus 1. Okay, so this is the new denominator for this second term. All right. Now, we have an x minus 1 here. We got to make sure all the denominator is represented. They get represented here in the new answer. Okay, the new answer is down here. Oh, we don't have a 2 down here, do we? Okay, so is everybody represented? Is the x minus 1 represented? Yes. Is the 2 represented? Yes. Is the x minus 1 represented? Yes. Don't list the x minus 1 twice. Okay, there's going to be some special occasions where we would list it twice, but I don't think it occurs today on this worksheet. Okay, so now, here's where we have to think a little bit, but it's not too bad if you'll just listen. Okay, we're comparing this denominator, this x minus 1, with this denominator. What's different about it? The 2. So that's what you multiply the numerator by, what's different. So if you want to say, instead of what's missing, if you want to say what's different, you might do that. I don't know how your particular brain works. You can ask yourself what's missing. Like, in other words, looking here, what's missing? Oh, the 2 is missing from here, right? The 2 is missing. So you can say, oh, that's what I need to multiply this by. Or you can say, what's different about it? Oh, the 2 is. So then I multiply the numerator by the 2. Okay? Which question do y'all like best to ask? The what's different or what's missing? Or you don't know yet? Huh? You like the what's different? Okay, so let's do a few more, then maybe you can decide. Okay, so from here, this is the new denominator. We changed this right here to this, to x minus 1. Okay, what's different about it from here to here? They're the same. Nothing's different, is it? So that means we don't have to multiply this 3 by anything. Nothing's different, multiply by nothing. Okay? So then we get 4 plus 3, which is 7 over 2x minus 1. Okay? Okay, so the first step is always to look at the denominator and do what? And factor, if something can factor. Okay, x plus 2 can't factor, but can x squared minus 4 factor? Yes. Okay, so how can it factor? Yes, it's one of those easy ones to factor. I think I've drilled it into your heads enough that a lot of y'all are seeing these now. You're able to see them and go, oh yeah, those are those easy ones. Okay, so now, in our new denominator, we're going to have an x plus 2 from up here. We're going to have an x plus, oh, we already have an x plus 2, right? Okay, so we don't have to write that again. And we're going to have an x minus 2. Is everybody represented? Yes. Okay, so now we just don't even look right here. Just don't look right here. Just cover it up. Okay, from this x plus 2 here to this x plus 2, x minus 2, what's different? The x minus 2. Okay, or you can ask yourself the what's missing question. You can say, looking at this x plus 2, what's missing from down here? The x minus 2. Okay, so we're going to multiply that out in just a minute. Let's go ahead and do this side. Okay, from here to here, comparing the two denominators, what's different about it? Nothing's different. Nothing's changed. So we don't multiply this 2 by anything. Okay? Okay, so now let's multiply. So 3 times x is 3x plus 6. And then don't forget our plus 2. Oh, yes, it's a negative 6. Thank you. I was kind of noticing that myself at the same time. Y'all were noticing it. Okay. Okay, so it's a negative 6, so don't make a mistake with your signs. Okay. Now we need to combine these like terms, don't we? So we have 3x, then what? What kind of a 4? Negative 4 over, or divided by, x plus 2, x minus 2. Now, look right here. Can I factor that? 3x minus 4? Do they have something they can both divide by? No. So we're good to go here. Okay. Questions so far? You'll get the hang of it. I promise. Y'all have gotten better at factoring, so you can get better at this. Y'all can get this down too. Okay, so look at your, is there anything we need to factor here? No. So x plus 2 gets represented. X plus 5 gets represented. Now we're ready to play the what's different game. Okay? Now, this is a subtraction problem, so we're going to have to be very careful. Okay? You have to be very careful with your subtraction. Okay, well, let's look at this one right here. 1 divided by x plus 2. What's different comparing the denominators? X plus 5. Okay, what's different here? X plus 2, right? Okay, so 1 times x plus 5, that's just going to give us x plus 5, right? I like it when that happens. Now, we have to be careful. This is a negative 5. I sometimes still, when I work problems, even I will circle that because that really helps it stand out so that I know that's a negative, to include that negative. So negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. Good job. Okay, now we have some combining of like terms we need to do up here. We got to put the x's together. Okay, we have a 1x minus 5x is negative 4x. 5 minus 10 is negative what? Negative 5. Can that negative 4x minus 5, can they both divide by something? Yeah, I mean, they can both divide by a negative 1, but that's not going to really, that negative 1 isn't going to cancel out with anything over here, so I would just leave it. Okay? Questions on that one? You may have questions later. Okay, I think this is the last one, but then I'm going to also help you on the first one on your homework, try to get you kind of jump started on your homework. Okay, so is there anything, can anything factor here? No, I'm also taking note that it's a minus also, so I'm putting that in my brain cells. Okay, so I have a 3 and a y squared and an x. Is everybody represented once, like they're supposed to be? Okay, so from 3y squared to 3y squared x, what's missing? X. Okay, from x to 3y squared x, what's missing? 3y squared. Okay. So 8x squared minus what? Because that's going to be a minus negative 21y to the third. Okay. So now look across here. Can 8 and 21 both divide by the same thing? 21 can divide by 7 and 3. Can 8 divide by 7 or 3? No. And they don't both have an x in common or y in common. There's nothing in common that we can pull out over here, right? So we can't factor that. So that's just your answer. Okay? Okay, so now let me pause the video for a second, if I can figure out how. And okay, so where did I do my pen? Here it is, right here. Okay, so this is the worksheet. So they give you a nice example. If you can follow along with that, that might help you. Notice here in this example, look right here, this 6 minus 4 made a 2, and then those 2's cancel out. Okay, but you still have to have something on the top. So sometimes that happens in a problem. You get some canceling out. Okay, so just to kind of get you started. Okay. So look at, let's make a new denominator with everybody represented. 3x and 2y. Now we'll multiply this 2 and 3 together in a minute, but it'll be good for your eyes and your brain just to leave it alone for right now. Okay, so you can compare easily. So when I compare this denominator to this new denominator, what's different? 2y. So we're going to multiply this by 2y. Okay, notice it's a plus. Always, always, always try to take note of what kind of sign you have. That'll make your life a little better. Okay, and comparing 2y to 3x 2y, what do we have? What's the difference? A 3 and an x. Okay, so let's multiply these. So what do we get? A negative 7 times a 2 is negative 14x y squared plus, I didn't make my line long enough, okay, what's 4 times 3? 12, and then an x, I'm trying to put them in alphabetical order, and then a y squared, right? Okay, so for one time, we rarely have this happen, but we have like terms. An xy squared is the same as an xy squared. Those are like terms, and like I said, we haven't had that really happen much at all. I don't even know if when we were doing all those other worksheets. So we can combine these. These are considered like terms. So don't count on that happening on some of these others, but this one it does. So negative 14xy squared plus 12xy squared. How many xy squareds do we have? What's negative 14 plus 12? Negative 2. We have negative 2xy squared over, what's 2 times 3? 6xy. Well, we know how to simplify these, don't we? Okay, what does negative 2/6 reduce to? A negative 1/3. What happens to your x's? They cancel, and then what happens to your y's? Yeah, you just get a y on the top, right? And so that can be your answer. You can have the 1 or not have the 1. Okay, if this were like on a multiple choice test, they probably wouldn't have the 1. It'd probably be gone. Okay, so that kind of gets you started. I will say this one, number 3, is a little goofy, but try it. Get started on it, and if you get stuck, look at